Welcome to the deep dive. Today, we're taking a stack of source material articles, research papers, incident reports, and really trying to pull out the crucial nuggets of knowledge you need to stay ahead.
Right.
Our mission today is to analyze what seems like a completely chaotic information landscape. We're talking about everything from, self-healing software worms and developer mistakes to these long-tail corporate breaches and, even malicious poetry.
It really does sound like science fiction, but it's where we are now. And if there's one red thread, one thing pulling all these seemingly disparate stories together, it's the need for individual security awareness and this constant negotiation of digital trust. That trust is being corroded everywhere, from the open source libraries that power, 90% of the internet?
Yeah, at least.
All the way to the device you buy on what you think is a legitimate storefront.
That's a perfect frame. Okay, let's unpack this.
Will do.
We have to start with a threat that is not new but has become dramatically more sophisticated. I'm talking about the Shai Hulud worm.
Now with one eye.
Right, one eye instead of two, which is causing, even more chaos than its first iteration. It was initially targeting NPM packages, but the newest strain is now infecting packages in Maven as well.
And what's fascinating here is just the sheer maturation of the threat. This is a fully autonomous worm.
Fully autonomous.
It spreads itself. It executes automatically. It requires absolutely no user interaction to propagate. Its main goal, like before, is to steal developer secrets. But the way it spreads, that's what makes it so dangerous.
How so?
It publishes malicious packages under the victim's existing, and this is the key word, trusted account names.
That's the whole attack, right? Leveraging that reputation. If I see a package update from a contributor I know and trust, I'm not going to think twice about it.
Exactly.
And the scale here is just staggering. The new strain has infected hundreds of NPM packages, some tied to trusted orgs like Zapier and Postman, and it's already compromised more than 25,000 repositories.
A number that's just way larger than the initial outbreak. It also shows a really clever understanding of modern security tooling. The worm now executes during the pre-install phase.
Hold on, why is the pre-install phase so significant?
Well, it's critical because of where the industry focuses its detection efforts. A lot of standard dependency scanners and security tools, they're designed to check files after they're installed.
Okay.
Or maybe during execution. By running during that pre-install hook, the worm just exploits this known blind spot in CI environments and local developer setups.
So it's basically invisible until the damage is already done.
That's it. The secret theft, the self-propagation, it's all happened before your tools even know to look.
And if it fails, if it doesn't find the secrets it's looking for, it doesn't just quietly quit, it turns into a wiper.
Yeah, it tries to delete the entire home directory. It's like throwing a tantrum.
It feels like a scorched earth policy when the primary goal is denied.
It is. And this dual-purpose nature stealing secrets and having this destructive wiper as a fallback, it really raises serious questions about the future of open-source trust. We rely on these platforms for rapid innovation, but every time a major supply chain attack happens, organizations have to question that risk-reward calculus.
And the reputational damage for the developer, who was the victim.
Yeah.
It's devastating. You can't just fix the package. You have to rebuild that trust with a user base that's now, really nervous.
Absolutely.
So beyond just telling developers, hey, be more secure, what tangible support do organizations need to provide now that developers are on this new front line?
It requires a profound shift in mindset.
Right.
Security experts need to stop acting as a department of right, just blocking everything. Yeah, focus purely on prevention. They need to start acting as enablers of how we do it safely. That means mandating secret management tools, no more secrets in environment variables or hard-coded. It means mandatory, rigorous peer review of dependencies, and maybe even adopting stricter access controls, like hardware tokens for publishing.
Bridging that gap between developer speed and security safety.
It's crucial. And it's fascinating because the developer community thrives on efficiency, but that efficiency often introduces risk. They prioritize speed, which is kind of why we saw this next problem emerge.
Speaking of human errors driven by convenience, let's turn to that research about developers leaking sensitive data. And they're leaking it to popular public code formatting tools.
Yeah, like JSON Formatter, Code Beautify, tools people use every day without a second thought.
Right.
So these offensive security researchers, they analyzed these platforms and uncovered over 80,000 saved JSON blobs. And inside were just these high-value treasures.
We were talking about SSH keys, Active Directory credentials.
And a massive amount of customer PII. Personally identifiable information.
So PII, just to be clear, That's any data that can directly identify someone, names, addresses, account numbers. Why on earth would someone paste active critical credentials into a public web tool that's just meant to make code look pretty?
It all comes down to cognitive load and convenience. Developers are under pressure. They need to quickly validate a JSON structure, and these tools are just instantaneous.
They don't stop to think?
They don't stop to think, where is this data being stored, or who else can see the saved history?
Yeah.
This isn't malice, usually. It's just human nature prioritizing speed over security.
And malicious actors are absolutely aware of this goldmine. The researchers planted fake, trackable tokens.
And saw threat actors trying to exploit them within 48 hours. The awareness is there. The exposure is live.
So while it's easy to blame the developer,
there is a shared responsibility. The tool providers themselves need to secure their platforms better, make it much clearer if data is being logged or saved. But from an organizational standpoint, this just highlights the absolute necessity for clear SOPs.
Standard operating procedures.
Right. Defining exactly what third-party tools are authorized and, more importantly, what types of data, especially non-anonymized data, are absolutely forbidden on those platforms.
But even with clear SOPs, we run right back into that psychological challenge of shadow IT.
Exactly.
Employees just circumventing rules because an unauthorized tool is easier. Or now, shadow AI with unapproved large language models.
Shadow IT is a cultural problem that rules alone just cannot solve. You can block tools, but employees will find workarounds if the official path is too hard. The solution isn't just prohibition. It's providing secure, sanctioned internal tools that are just as convenient as the public ones.
Security has to be frictionless to be adopted.
That's the only way.
Okay, let's pivot now to a case that shows the disastrous long-term consequences of failing vendor security. The Gainsight attack.
A multi-stage breach.
Yeah, 200 companies compromised after hackers hit this customer support platform and then used that to get into their Salesforce data via connected apps.
And if we connect this to the bigger picture, the timeline here is the crucial lesson. This wasn't a one-day smash and grab. The initial access that led to the Gainsight compromise, that happened months earlier.
During the SalesLoft breach, right.
Precisely. During the widely reported SalesLoft breach, the attackers there stole authentication tokens, specifically from the embedded Drift chatbot.
So SalesLoft and Drift were the initial point of failure, but Gainsight, a totally unrelated vendor, was the eventual target used to reach the ultimate victims. That is the definition of a domino effect across the vendor ecosystem.
That's it. The attackers used those previously stolen tokens, which, crucially, have been granted persistent access, to move laterally into the Gainsight environment.
And because Gainsight had that system-to-system trust with 200 customer Salesforce instances,
those 200 companies were breached months after the initial event ever happened.
It just underscores the profound risk of persistent OAuth tokens. You grant a third-party SaaS vendor access to read, maybe even write, to your core business data, and you don't really think about what happens if that access falls into the wrong hands 6 months from now.
The security implication is that every breach in your vendor ecosystem has a long tail. You have to have robust vendor due diligence, and you need proactive revocation strategies. Organizations need to be asking, are these OAuth tokens scoped right? Do they expire?
Or are they just indefinite access?
Which is what happens all too often. Vendors request these overly broad, persistent permissions for convenience, and organizations just blindly grant them.
So when a breach happens anywhere in your supply chain, your security team needs to assume it will touch everything they have access to. But with so much threat intelligence coming in all the time, how do you even prioritize that?
Well, you can't chase every threat on the globe. Defenders have to focus their threat intelligence efforts on, let's call it the fires that are really close to your house.
Right.
If a vendor in your immediate chain, like SalesLoft in this example, is compromised, you treat that as an immediate existential threat to your organization, and you act on it. Now, you still take shared information seriously, but you prioritize based on proximity and access.
That makes sense. Our next story brings this fragility of trust right into your living room. We're talking about these so-called super boxes.
Cheap Android streaming devices.
Yeah, sold through entirely legitimate channels, major online retailers, brick-and-mortar stores.
These devices, they promise you free streaming, and they deliver it via these sketchy, unauthorized apps. But the hidden part, the deception, is that they secretly conscript your home internet connection as bandwidth for a proxy network.
So they're feeding botnets.
Feeding botnets and other malicious activity, all without the consumer ever knowing.
Now, this might sound like it's purely a consumer issue, but it has huge enterprise risk ramifications.
Absolutely. We're in a work-from-home world. If these compromised devices are sitting on the same local network as a corporate laptop, there's an immediate opportunity for risk, for lateral movement into corporate assets.
It creates this serious paradox of trust for the consumer, doesn't it?
Yeah.
We're always telling people to shop at legitimate, trusted stores. But these major platforms, Amazon, Best Buy, you name it, they're increasingly just distribution hubs for untrusted third-party
You
sellers.
can no longer rely on the retailer's name as a guarantee for product safety.
So how does an organization defend against a malicious piece of hardware that's operating on an employee's home network? A network they cannot and frankly should not be surveilling.
The primary defense has to be personal ownership, but empowered by corporate policy. Organizations have to realize they can't control the devices on a home network. So that means you need extremely strong endpoint detection and response, EDR, on the corporate laptop itself.
Right.
And robust network segmentation for work-from-home setups. If a corporate laptop has to be on the same network as a smart TV, that laptop needs to be as isolated as possible.
And it really speaks to the value of just good personal security hygiene, doesn't it? If you practice good personal security like enabling MFA, multi-factor authentication on all your accounts, that preparedness just translates into better decisions at work.
It does. It's about building that mental firewall where you actually question the reward versus the risk for that 5-second convenience.
Right.
If the device requires you to sideload a suspicious app or rip out security services just to get free content, you have to pause and think, what am I trading for this?
That's the core question. Is this the right decision? Am I making the right choice? Am I trading 5 seconds of convenience for months of headache?
Precisely. And in a security context, your gut instinct is usually right.
Now, for the most creative and maybe surprising finding in our sources today, Poetry is the new hacking tool.
Chuckles.
We have a research paper titled Adversarial Poetry as a Universal Single-Turn Jailbreak Mechanism in Large Language Models.
This is a truly fascinating collision of art and engineering. The researchers found that phrasing malicious prompts as complex structured poems, with meter, rhyme, metaphor, is remarkably effective at bypassing security guardrails.
On 25 different LLMs, including huge ones like Gemini, Grok, and versions of ChatGPT.
The success rates are surprisingly high. The researchers' original malicious poems hit an overall success rate of 62%.
Wow.
And even when they took standard prose prompts and just had a machine convert them into poetry, they still got a 43% success rate.
So it's the poetic structure itself that's the weapon?
It is. It highlights the art of jailbreaking. We teach LLMs on these massive data sets, and we try to instill ethical guardrails using specific prose instructions. Do not generate content related to X.
Right.
But when you present the request as a poem, it just changes the linguistic context. The model treats it less like a direct command and more like a creative exercise.
So the guardrails fail their pattern matching checks.
Exactly. It's like presenting a logical problem as an emotional plea.
And the variance and resilience is really telling. Gemini was at a 100% success rate with this method.
Every single malicious poem worked.
While some versions of ChatGPT were much tougher, only 0 to 10% success.
And that variance just shows the ongoing, rapid-fire nature of this cat-and-mouse game. As soon as a defense is built, an attacker finds a way around it. It means we have to be continuously training and testing.
We have to try to jailbreak our own models.
We have to. It's the only way. You have to embrace this philosophy of constant vulnerability testing. Train the model, then hit it with every creative linguistic trick you can imagine.
We have to be ready to adapt to the attacker's creativity, not just their code.
Absolutely. We must always, in every context, whether it's code or language models, trust but verify.
We've covered a lot. Shai Hulud's automated chaos, the human element in developer secret leaks, the months-long fallout of the Gainsight breach, and the creative threat of adversarial poetry breaking AI. So what does this all mean?
I think the core lesson for you, the learner, is that due diligence and vigilance, they're now personal and non-negotiable. They have to be applied at every single layer of the digital stack. Whether you're dealing with open source code, a quick formatting tool, a trusted vendor, or a cheap device on your home network, the moment you assume trust without verification, you create the attacker's greatest vulnerability.
And here is a final provocative thought for you to explore on your own. We saw poetry used to bypass AI security. Cybersecurity is so often described as this battlefield of code, right? But what if the most powerful defense systems of the future aren't broken by technical exploits, but by creative language and the exploitation of linguistic context? And if the goal of a malware reverse engineer in a honeypot is to observe the toxic sludge of an attacker's behavior to learn their methods, how can we apply that deep observational learning to our everyday interactions with technology? Watching the threats around us to build better internal defenses. Thank you for diving deep with us.